Welcome back to Project Geospatial. I'm Adam Simmons, and this is the Industry Limelight. In this segment, we have the pleasure of interviewing Elly Perets of Asterra to talk about their new patent announcement around mineral exploration with the initial focus of finding lithium with synthetic aperture radar. Let's dive right in. Our first question is, who is Asterra and what is the current business focus?
My name is Elly Perets. I'm the CEO of Asterra. Asterra is a company that specialized in analyzing synthetic aperture radar to improve infrastructure resiliency. In a nutshell, we are capable of taking 15% of the spectrum and allow humanity use that insights for the good of everybody. Specifically, we are focusing on infrastructure, as infrastructure is failing all around the world. Infrastructure is getting older much faster than the rate of improvement, than the rate of replacement, and there is no budget in the world that can fix it right now. So the only effort that makes sense right now is to go to the right locations and allocate resources according to where is the right place to handle. Asterra is helping by identifying the locations using synthetic aperture radar. In some of the areas we're using ground penetration radar to see what is happening above the ground and below the ground, and the interaction between the ground and the infrastructure. That's our technology, and this is what we have done for the last 6 years successfully. Recently, we have introduced a new technology that is in the area of exploration of minerals around the world, helping the mining market in another segment or another vector above and beyond what we are doing right now.
Let's dive into the new patent announcement. What is the new patent and the new capability being introduced?
A little bit of background. Synthetic aperture radar can be used in so many different segments. Earth observation in general is an excellent way to collect large amount of data for different applications. And in the last 18 months, I have tasked a few people in my organization, the founder, the CTO, and a few other people, to identify the next segment of how our technology can help humanity. Part of the investigations were around what we heard from our existing customers, our miners, in regards to the difficulties to go through an exploration process. The exploration process is the process that is pre-mining. Where do we build the mine? And what is the potential of a certain area to give us the minerals that we hope to generate? The technology is based on the ability of synthetic aperture radar to penetrate the ground and to identify the signature of different materials. Each material has a specific signature which is coming from the electrical capacity of that material, the electric constant. Hence, every material like cobalt, lithium, copper, and so on react differently to the wavelength, assuming that it's close enough to the surface. We have taken our ability to analyze SAR, we have taken our ability to use machine learning to generate accurate data based on even not that big of a sample. And in the ground engineering market, it's very difficult to collect large sample. And we successfully managed to identify lithium, concentration of lithium in different places around the world.
Can you discuss how you went from looking for water leaks to lithium?
So it started by already providing solutions for miners in the area of ground movement and safety, tailing dams and other applications which are relevant to miners that get us close to that market, and we got to understand what are the other needs. Apparently, one of the major problems that they have is in the early stage of what they call exploration. During that process, they're spending a lot of money a huge amount of effort over many years is going into the process of questioning where am I going to build a mine and to what extent this mine is going to provide to the miners enough mineral to justify the effort. The amount of effort is translated into carbon emission, is translated into holding lands and preventing communities to use those lands for their own needs over many years, let alone the money, the effort, and the time that it takes. We, as a company that focus already on impact, on improving health of the planet, we understood that by focusing the effort of the exploration to the places of where there is higher likelihood of finding the mineral, is going to help everybody to reduce the effort, reduce impact on the land, and focus on the places where those mineral needs to be found. Moving into electric cars is going to overall improve the situation on Earth. There is a cost to it. The cost is that we will have to take some minerals from the ground and mine the ground. If we will do it in an efficient way, it's going to make the whole supply chain be more, I would say it will reduce the impact of humankind on the ground. Our mindset in regards to infrastructure, resiliency, improving human impact on Earth is within everything that we are doing, including the mineral exploration process.
How do you plan on integrating this patent technology into your current business?
The mindset around finding the mineral in the ground to improve independence, I would say it's similar to what happened in the 70s. Make sure that the US is energy independent to be able to supply its own capacity for itself, not being dependent on other countries, not being dependent on importing lithium from other areas, has been recognized already by most of the players, let alone the government. There is a blueprint that the government, the federal government, has already released in regards to lithium, and that blueprint already provide a clear agenda. We need to find, I'm talking about the US government, we need to find our own lithium, we need to be independent, we need to be able to generate our own needs in terms of lithium for the next 30 to 40 years. So that's when it comes to market awareness. We are in the very early stage of the lithium mining process. There are about 6 stages from the exploration process stage all the way to the point that the OEMs, for example, all the car manufacturers are putting a battery into an electrical car. We are involved in the first 2 processes, which is the exploration, and once a mine is in place, within the permit of where the mine can work, where else the miner can go and explore and then find lithium. So that's in the early stage. The companies and entities that are in that space are already mapped. There are not too many of them. And those are the companies that we are approaching. I would also say, and it doesn't take too much to look for that data, the OEMs are already getting involved in the early stage. So a quick look on what is happening with Tesla, Mercedes, Ford, and others would quickly show you that they are already going to upstream, looking for how can they secure supply of lithium for the growth that the market is planning for lithium batteries all over the world. Not only that lithium consumption is going to grow by major multiples in the next 10 years, 90% of it is going to go to electrical cars.
How do you see this technology scale in the near future?
Right now, the market is divided between Australia, China, and Chile, and there are close to very few to zero mines of lithium in the US. So when we're looking on the stage where the US market is at this stage is identifying locations that can be potential mines for the future. So we are in a very, very early stage. It can be considered like a blue ocean from our perspective. There is a huge need. There is a clear agenda all the way from the government for the OEMs that it needs to be done. There are sites already that are identified as potential, but it goes over a very large area or a very large territory. Where we get involved is in the point that we are narrowing down the locations of where to actually run the exploration process from a very large area to much smaller area. It can be few percent. So if currently they would need to go over a very large area, if we can give them the 2-3% of the area that is relevant, that's a huge advantage for them. Currently, the process can take any time between 1 to 3 years, and it can cost anywhere between $2 to $25 million per site only to verify that there is enough lithium to mine there. That's before anyone is going and building a mine over there.
What are the advantages and historical limitations of using SAR for your analysis?
So our technology is based on what we call PolSAR, which is different than InSAR. InSAR is the usual use of SAR by taking multiple images and measuring the differences between the images. PolSAR is using one image or very few images and measuring the difference between the polarizations within the image. So our advantage is that although we are fully dependent on the sensors, we need much less than any other technology, much less of tasking than any other technology. If you would have asked me this question 5 years ago, I would say it's very limited. There are not enough satellites, and there will be limitation on capacity in order to support that effort. Now, 5 years later, it's not that I'm happy with what we have, but the situation has dramatically improved. There are already few satellites that are available. They are in good quality. They have not been built for mineral exploration. They were built for InSAR and other applications, but we know how to repurpose the data for our need. And looking into the future, there will be more and more of that. Thinking of what can be done with that application, maybe someone will pick up the opportunity and launch a satellite for not only lithium, it can be any mineral exploration around the world, focusing on that application only, because I think that the potential is huge.
How soon can we see Asterra implement the patent technology within their current line of business?
We've already worked with a couple of design partners where we use the data that we got from them to improve our technology and to test the initial results, and the results looks very good, and the output is very promising. So we are already working in the field with the type of potential customers that can be or may be the future market potential for us. I would say that we are going to run few more tests within this year, and we will go to the market by the beginning of 2023.
Do you hope to expand to other minerals beyond lithium?
At the end of the day, the patent is about mineral exploration using machine learning in general. So it must be a mineral that has indication close to the surface. It doesn't mean that the miners are going to mine this mineral close to the surface. They can go very deep, but the indication should be close to the surface for us to pick it. And any mineral that has strong enough of a dielectric constant that we can pick by our satellites, or by this, not our satellites, the satellites that we are using, is a potential for exploration. I would even say that the limitation right now is not the technology, the limitation is the sensors. So as the sensor would be improved, would be more accurate, or it can be even a sensor that can be flown by an airplane. It doesn't have to be a satellite. I think that there will be more and more of use of it for all kinds of minerals that I would say indicating that they exist from the ground.
Do you have any final thoughts about Asterra and the patent announcement you'd like to tell everyone?
I do want to indicate that for many, those type of technology sounds like science fiction or fairy tales. It depends on what type of belief one is. And we are used to it. We are used to it from the very first product that we released to the market, Asterra Recover, which is a leak detection product. And I think it was our statement at that time, we can detect leaks from space. Can only imagine what people thought about this idea. Asterra is a company that operates already for 6 years in the market, providing value to over 300 customers all around the world in 70 countries. Asterra is generating revenue in a very nice gross margin, and this is not a technology that is made by bunch of people with ideas without knowledge. We have a very, very deep knowledge and very strong experience in identifying and locating phenomena in the ground and under the ground. So it took us long to come to that point, and it took us long to build that technology. The second aspect, which I'd like to highlight, is the combination of geophysics and machine learning. Asterra was founded by geophysicists. Asterra was founded by people that understand how wavelengths interact with the ground. We came to the point that we are implementing machine learning in our products only after we had large enough of a sample, large enough of a training set of indications of what worked and what didn't work with the geophysicist knowledge. The combination of geophysicists and machine learning is a winning combination. This is where we put, I call the geophysicist the doctor of health, of Earth, the doctor of health with machine learning engineers, and together they can find cures to the problems that we create.
Thank you, Elly, for giving us an overview of Asterra's new patent technology focused on the exploration and discovery of lithium using synthetic aperture radar. We can't wait to hear about the success stories on how you evolve this new capability. With that, I'm Adam Simmons of Project Geospatial. Thanks for watching. Be sure to subscribe to our YouTube channel and check out the rest of our content at www.projectgeospatial.com.